Hi everyone, today we're going to learn about logarithm basics. We want to learn how to convert logarithm to exponential form. First of all, let's see what is a logarithm before everything. We've already learned about exponentials. Like for example, if I have 2 to the power of 3, that means we are multiplying 2 3 times by itself and it's equal to 8. So if I ask you what is 2 to the power of 4, you're going to multiply 2 4 times by itself and it will be equal to 16. But what if I ask you this question? 2 to the power of what number is equal to 16? So you need to know how many times you should multiply 2 by itself in order to get 16. The answer of this question is actually called logarithm. Logarithm of 16 with base 2. This means how many times we should multiply 2 by itself in order to get 16. The answer is always an exponent, like the exponent of the 2 to get 16. So to define the word logarithm, we can say the meaning of logarithm is actually this question. This question is actually the meaning of this logarithm. B raised to what number is equal to A? B raised to the what number is equal to A. This is how we can actually give the meaning of a logarithm. Here's another form of exponential and logarithm. B to the power of x is equal to a. If I want to change this to log form, I'm going to write it in this way. Log this a, which is the answer of exponential, goes here as the argument of the log. B here is the base of the exponential. So the base going here as the base of log as well. And this x is the exponent of the exponential expression. So this is exponent. And obviously using this loop could help us go back to exponential form, like base to the power of the exponent is equal to a. So this loop always helps us change from log to exponential form. For example, 4 to the power of 2 is 16. So change to the log form. Log of 16 with base 4 is equal to the exponent 2. 5 to the power of 2 is equal to 25. So log of 25, notice always the answer of the exponential is the argument of the log. The base of the exponential is the base of log as well. And the exponent will go on the right side as the answer of this log. So 5 to the power of 2 is equal to 25. In this example, 3 squared is equal to 9. So we're going to change this to log form in this way. Log of 9 with base 3 is 2. That means 3 to the power of 2 is equal to 9. We were asking actually 3 should be multiplied how many times by itself in order to get 9, or 3 should be raised to the power of what number to get 9. Let's try these numbers. Log of 8 base 2. So 2 to the power of what number is equal to 8? Means how many times should we multiply 2 by itself in order to get 8? And we know that we should multiply it 3 times. So this is 3. What is log of 625 with base 5? How many times should be 5 multiplied by itself in order to get 625? 4 times. That means 5 should be multiplied by itself for 4 times. So 5 to the power of 4 is 625. Log of 81 base 3. How many times should I multiply 3 by itself to get 81? 4 times. So I should multiply 3 4 times by itself to get 81. 4 goes here. So 3 to the power of 4 is equal to 81. There are some special cases here. A log of 1 with any base is always equal to 0, because if I change this to exponential, this will be b to the power of what number is equal to 1. So we want to know b to the power of what number is equal to 1. We know that any base is always, if any base is raised to the power of 0, it's equal to 1, no matter what is my base. So because b to the power of 0 equal to 1, so the answer of this log is 0. And in this case, log of a with base a. So if you have a number, you want to take the log of that with the same number. This is actually, the question of this log is actually a to the power of what number is equal to a. So we know that if you raise a to the power of 1, that's equal to itself. So the answer is 1. The next part of the lesson is talking about common logarithm. Common logarithm is any logarithm with base 10. Because this base is a very common base in like all the math concepts, usually even on your calculator you can see that we have a key specifically for log with base 10. This is a logarithm that is used a lot. That's why we call this common logarithm. So let's see how does that work. For example, here we know that 10 to the power of 2 is equal to 100. So if I change it to the log form, it's going to be log of 100 with base 10 equal to 2. That means 10 to the power of 2 is equal to 100. Or here 10 to the power of 1 is 10. So log of 10 with base 10 is equal to 1. Whenever you have a log with base 10, you don't have to write the base of 10. You can easily just omit this part and write it as log of 7. So if you see a log without any base, that means the base was actually 10. Let's say, for example, you remember if you have a to the power of 1, we say we don't need to write the 1. It's just equal to 8. You don't have to write that. This is similar to this case. If you have the base 10, you don't have to write the base as 10. Now let's simplify this log. Log of 1000. If I don't see any base here, that means my base was actually 10. So I'm interested to know 10 to the power of what number is equal to 1000. So how many times should I multiply 10 by itself to get 1000? 3 times. So that should be 10 to the power of 3. So 3 goes here. Whenever you have a base 10, we know that if you just count the number of the zeros, that is how many times you should multiply 10 by itself to get that number. So here I have 1 million. Base is 10 because there's nothing written here. That's why the base is 10. So how many times should I multiply 10 by itself to get 1 million? As you see, we have 6 zeros here. That means 10 has been multiplied by itself for 6 times to get this number. So this is equal to 6. The next thing that we're going to talk about is Neperian number and natural logarithm number. Neperian number, which is also called Euler's number, is called after Leonhard Euler, who discovered this number. This number is an irrational number, means it cannot be written as quotient of two numbers divided by each other. And it's equal to 2.78218 and so on. So this number never ends and is continuing forever. But we can simplify it as just 2.7 and just write it as E. So we always call Neperian number as E equal to 2.7. So this is Neperian number or Euler number, and any logarithm which has the base e is called natural logarithm. Like for example, if I have log of, let's say, x with base e, this is actually log of x with base 2.7. This is called natural log. We do not have to write it as this form. We can write it as ln, like natural logarithm of x, and we don't even have to write the base e here. If you just write ln, that means that's actually log with base e, or 2.7. So here we have an example. If I have e to the power of y equal to x, this e is 2.7, so this is actually 2.7 to the power of y equal to x. We don't have to write 2.7, we just use it as, refer it as e. So if I change this to the log form, it's actually log of x with base e, which we know that e is 2.7 something. Now, again, instead of writing log of x with base e, you're going to write just natural log of x, or ln of x. And that's actually, in this example, is equal to y, because e to the power of y is equal to x here, in this case. If I have e to the power of 1, we know that e to the power of 1 is equal to e. So change it to the log form. It's going to be log of e, so this e goes here, and the base is again e, because e is to the power of 1. So I can rewrite this as natural log of e, and it's equal to 1. This is a special case that we always need to learn. Remember, natural log of e is 1, because this is log of a number with the same base, and we learned this before, that natural log of a number with the same base is equal to 1. So let's do some examples. We want to change this in natural log form. We said if you have log of a number with base e, you don't have to write it in this way. You can just write natural log of 29, and that's it. Now let's work on some exponential expressions with base e. Whenever you see e, you don't need to freak out or say, what is this number? What should I put instead of this? You don't have to do anything about this. Just keep it as it is. We know that e is equal to 2.7, but here, because we're just trying to simplify, we're not trying to evaluate this number, you don't even need to touch this. So keep the base, and we have the rule of this property, that if you are multiplying two exponentials with the same base, you can add up the exponent. So this is e to the power of 3 plus 4, which is e to the power of 7. If you want to know exactly what is the decimal number of this, you can use your calculator. On your calculator, you can see a button defined for e, and that's here. On the division key, you can see a small blue e here. So if you want to access that, you're going to do second division, and that's e, which is equal to, if I put enter, gives you the value, the decimal value of that 2.7 something. If you want to raise e to a power, you can use this button. You see the ln button, on top of it you have e to the power of x, so you go second ln is e to the power of something. So I want to know what is e to the power of 7, so I put 7, and then it's equal to 1096 something. So in order to evaluate the exact decimal number of these expressions, you can use your calculator. In this case, we have again two e exponential terms, and we want to simplify that. We have two terms with the same base, so we keep one of the bases and then add up the exponents. So 1 plus 4x plus negative 2x. So this will be e to the power of 1, and then 4x plus negative 2x will be positive 2x. So this is the answer. And this one, e to the power of 3 to the power of 2. You can just multiply the exponent. So this will be e to the power of 3 times 2, which is 6. You can even use your calculator in order to find the exact decimal numbers. However, in this special case, we don't have to do that. We're just simplifying. But I'm going to show it to you how to find it again. So we go to second ln e to the power of 6. So this gives us the answer. If you put enter, is 403 and something. 403 and something. Now let's find this problem, work on this problem. Evaluate without using a calculator. So in this case, I have ln of e to the power of 3. So we know that if you have natural log, ln is natural log, the base is actually e. So I want to know e to the power of what number is equal to e to the power of 3. So e to the power of what number is equal to 3, and that's absolutely 3. In this case, we have 2 times ln of e. We know that ln of e has the base e, so e to the power of what number is e? It's 1. So I know that this part is 1. Now I have 2 times 1 is equal to 2. Once again, if you have natural log of e, that's equal to 1. And we know that natural log of any number with the same number is equal to 1. So we're using this property here. And now this time we have e to the power of ln of 5. So here in this case we need to see what is e to the power of ln. To solve this, let's just consider ln of 5 is equal to something, x for example. So that means if I change this to exponential, this will be e to the power of x equal to 5. On the other hand, we just considered that ln of 5 is equal to x. So that means this is x. This whole thing is x. So I have e to the power of x. So what is e to the power of x? We just figured out that is equal to 5. So this is 5. Just consider this as another rule that e to the power of natural log of anything is just equal to a. This can be considered as a general rule. So I don't need to do all these operations. I just use this rule and say e to the power of natural log of anything is equal to that thing. Now this one is what is natural log of 1 over e, means e to the power of what number is equal to 1 over e. E to the power of what number is equal to 1 over e. We can change this 1 over e as e to negative 1. So now we can easily say that that number is negative 1. So the answer of this is negative 1. You need to practice more to learn better about this concept. Have a great day.